All right, earlier we studied the shift transformation techniques, right? So now let's look at an example. What if function have multiple changes, multiple steps of shifts? All right, so let's look at this example. F of x equals absolute value plus 3 minus 5. And I ask you to graph this function and then find the domain and the range of the function. So where to start? First, given you this function, you need to find the key function in our library. Okay, so where we want to start? We want to start with key function in the library we can identify is the absolute value function, right? Because we see here have an absolute value bar. So we start from here and then see what kind of transformation we can get a graph to this one. All right. So first we want to, get this one. Inside the function, right? Replace x by x plus 3. Okay, so first plus 3, right? X plus 3. So that's adding, subtracting. So the transformation techniques we can determine must be a shift, right? And then it's a x change, right? Second step we know is a x change. Why? Because it's inside absolute value, right? If it's a y change, it will be outside of the absolute value plus or minus 3, right? So this is an x change, and then we know it's a horizontal shift, right? And then next, horizontal shift, there's two directions, either left or right. So which one is that? So we have to write as x minus k, right? In our case, x plus 3. So we have to change to the minus negative 3 in this case, right? Therefore, we derived k must equals negative 3. Is that right? Only x minus negative 3, we can get x plus 3, isn't it? So be careful, here is a one-time sign change. So k equals negative 3, therefore we know must be horizontally shift to the left-hand side, right? 3 units. Okay, and then what about the graph? So original absolute value function is V-shaped, right? Here is the 0.11. This is negative 1, right? Now we horizontally shifting to left-hand side 3 units. So 1, 2, 3, and then this is a y-axis should be here, okay? So it should be like that. We should horizontally shifting to left-hand side 3 units. All right, so now our function get absolute value of x plus 3. But eventually we want to get absolute value of x plus 3 and then minus 5, right? So we need a one more step transformation. So from f of x equals absolute value of x plus 3, and then outside we minus 5 again, right? So minus 5 plus minus, so still shift. Okay, so this time it's an x change or y change? Outside of the function, right? Now f of x equals x plus 3, so we can rewrite this part is the same. Outside of function minus 3, so this time is the y change. Okay, y change is the vertical direction, right? Either up or down, right? Only two possibility. And then minus 3 is vertically shifting down, right? 5 units. So from here, okay, not go back to original place because we already go through one-time transformation. So initial graph, this is a f of x equals absolute value of x. And then until here, that's f of x equals absolute value x plus 3. And then one more step transformation, vertically shifting down 5 units. So -1, -2, -3, -4, -5. Okay, so that will be right here. Vertically shifting down 5 units. So from the previous steps, okay, or previous graph, vertically shifting down 5 units. So now this coordinates will be what? From 0, 0, right, left 3. So x coordinates is -3, and then down 5, y coordinates is -5. All right, that's the final graph. And then what about the domain and the range? Okay, initially f of x equals, f of x equals absolute value of x. Original domain and the range is what? Domain will be all real number, right? Doesn't have any restriction for x. And then the range, what is original, will be from 0 to positive infinity, right? K equals 0, so square brackets this side. All right, that's original absolute value of x. Now, after we left 3, right, and then down 5, and then what will be the domain? Domain, still all real numbers, right? Doesn't matter, even though we shifting to left-hand side 3 units, but it still be all real numbers. So domain is still all real number. And then the range, what that going to be? From 0 down 5 units, right? So that will be from -5 to positive infinity. This is the new function's domain and range. I hope that makes sense to you. Okay, so we go through 2 steps of transformation from the key function in the library, absolute value function, and then get a graph of this function. Okay, 2-step transformation is first step, horizontally shifting to left-hand side 3 units. And the second step is vertically shifting down 5 units. Okay, vertically shifting down 5 units. So 2 transformation got here. And then we can look at the more accurate graph, okay, step by step. This is original absolute value functions graph. This is after first step transformation, horizontal shifting to left-hand side 3 units. And then this is second step transformation, vertically shifting down 5 new units from the previous transformation. Okay, that's the final graph. And then the vertex is at -3, -5. Okay, that's the example combines horizontal shift and vertical shift, 2 steps transformation, and then we finally get a graph here.